Now, your question would be, okay, how will be the question on footing design in the interview? So they will give you some data for the footing design. They will give you what is the axial load coming on the footing. They will give you whether some axial moment is acting or moment about both the axis acting. And they will also give you SBC, and they will ask you to design. So it's kind of a written test. You need to solve it on a paper or maybe screen. I don't know. It depends on what is the mode of interview. Now, uh, this design process we have already studied in our fifth semester in the subject design of RC structure element. We know the procedure. Now, your very first thing what you have to understand is whenever they ask you a question, what is that they see or what will be tested? You should first understand, say for a footing design, when they give you data, you should first things first, you should know what are the important steps in footing design. Now, what are the important steps in footing design? First is we find the area of footing. We know the SBC, we know the load. So first we find the area of footing required. Then what we check? The base pressures. So we have stipulations for maximum and minimum pressures. So that we need to specify. After that, there is finding the depth with one-way shear and two-way shear criteria. What is the depth we fix? And then AST and other things, minimum still and all those of checks. So important these steps you need to write it down and you need to perform some calculations. Calculator will be allowed. It's not a big deal. They might allow calculator also. You should know the important steps to do the footing design. Now, important part here is not to remember the formulas, remember the steps and all. Even if you broadly remember how the footing design is done, you can solve a footing design problem. But data interpretation is seen here. For example, what does data interpretation mean? So generally we read that SBC will be given, in the footing design problem. Instead of SBC, they will tell that allowable bearing pressure of the soil is, say 120 MPa, 120 kilometer per meter square, whatever the units are. Now, once you hear allowable bearing pressure instead of SBC, many people start to get confused whether allowable bearing pressure is same as SBC or allowable bearing pressure is something very different. So they just give you to a little bit confuse you. So you have to read from the good books. If you have understood the process, what SBC means, what allowable bearing pressure means, it will not, be a major problem. But data interpretation is very important. You should know, for example, moments or SBC or the other data, whenever they give you, you need to understand the difference between SBC, why in what cases it is called as allowable bearing pressure, whether allowable bearing pressure is something very different from SBC. All these things concept wise you should be knowing. Again, how to prepare for such questions? Study any good book, say Pillai and Menon for RC structural design. All the definitions are given. What is SBC? What is allowable bearing pressure? Problems are solved. So you need to have an idea of that. So also, while you solve such questions, please remember the presentation or the documentation is equally important. For example, when they give you data, don't just solve it like how you do in a rough calculations. Never do that. First step, write the given data, write steps. If you remember the formula, well and good. Try to be in a neat, documented, presented manner, like say a steel calculation, then one by one, what are the steps. So presentation is also seen. You'll be most probably asked to solve it on a paper and then send it that the results of that across, maybe say on the screen they might ask you to show, or they can ask you, they might ask you to share the results of this written test via email or whatever means they prefer, or if it's a walk-in, directly they'll evaluate there itself. So this is in the footing design. And not just this, in footing design still there are a lot of things which you need to be uh, uh, giving importance to, giving care to. Now, you should understand the process. Say when they give SBC 120 kilonewton per meter square, you should also know that if with that SBC you find the everything area, you find the pressures are also say within limits, maximum pressure, minimum pressure. Now, what you will do in cases where the SBC is restricted? Now, think this from a real project. Uh, think like you are not having any soil results. Generally, if you are a structural engineer, if you are designing a footing, you conduct soil test for the building. Then, whatever SBC you get from the soil results, that you should be using. Now, be one step ahead. Think, when you're not having this SBC, how you take these results. As a structural engineer, you cannot say that, okay, SBC value is not there and I cannot do my footing design. This is not how a structural engineer thinks. You should be knowing when data is not available. If you are to assume in the data, sometimes they may not give the SBC value. They might ask you to assume SBC as per some background or basis. Say if your company is Bangalore, or say if the area is Bangalore, they might ask you to assume the SBC accordingly. They may not give you data. In such cases, your responsibility, your duty as a structural engineer is to know what are the different types of soil, what SBC it can have. Say for red soil, what is the SBC? There was one code, I am not remembering the name of the code, but it gave values based on the soil type. Although that code is superseded now, but still it gives a very good idea how much value you can assume. Also, you need to understand as a structural designer, in lot of real projects, you may not be having the liberty to choose any SBC you want. SBC will be limited or capped or restricted, say 100, maximum 120. In that, you need to satisfy the pressures. You need to find a footing design. You need to do the loads coming on. You need to transfer it safely through the soil. So footing design means not just solving any random this thing. You need to understand when SBC is limited, capped, or restricted, what are the things you can do. You need to also understand this satisfying base pressures. That P max, what you do, P by A plus M by Z, and minimum pressure P by A minus M by Z. If you are not able to satisfy, so the maximum pressure should not be greater than SBC. Say your SBC is 200 kilonewton per square or per cubic meter. That maximum pressure should not cross the SBC, and also minimum pressure should not be negative. It should not be less than zero. So you need to be thoroughly knowing, in cases where the maximum pressure, suppose you solve the footing, your maximum pressure is coming more than SBC. What needs to be done, that you should understand. You should understand how the maximum pressures, if it is exceeding the SBC, how you can reduce it down. And if your minimum pressure is coming less than zero, so all of those things you should be knowing. What code is suggesting, whether code is allowing that negative pressure to develop or not. So if you see this pressure, so if it's a concentric footing, you'll be having some pressure distribution like this. There will be some maximum pressure, there will be some minimum pressure, there will be some variation. You need to understand how this variation comes. What is the maximum limit as per code this maximum pressure can go. What does the code prescribes about the minimum pressure, what is the range. So again I said, uplift is something very important in footing design. Here, as you can see, both the maximum pressure and minimum pressure are positive. If this is a concentric footing, you can see that load is acting through the centroid of the footing. In cases, say, where column is here, footing is here. So CG of column lies somewhere here, CG of footing lies somewhere here. Column CG is not coinciding with the footing CG. There is some eccentricity here. So in such cases, what does the codal provision say? How do you design that footing? If there is eccentricity with respect to column and CG, what problems does it cause in footing design? You should be very well know in the interview. So this is called as, whenever there is some cases, there is something called as uplift. Uplift means, uplift means the maximum pressure, okay, it will be positive and it will be, say, less than the SBC. But minimum pressure, it will go less than zero. So this pressure diagram you cannot have, because as you can see, soil cannot take tension. So whether or not are you allowing any tension, or whether in some load cases, whether you tension is allowed or not, everything you should be knowing process. Say for the gravity load cases, you are not allowed to have any tensions. But say when it is a wind load combination, say when it is earthquake load combinations, such combinations do not all the time act on a structure. So whether or not in such cases, whether some uplift, we do not say like entire uplift in the footing is allowed. Whether some uplift, say 10% of the contact length, 15% of the contact length, whether it is allowed or not, this is called as a consulting practice. there are two different things. One are the codal provisions. One is the consulting practice. I'll help you understand what is the difference. Codal provisions are the things which you are bound to comply with. For example, if the code say no for tension allowed, there is no tension allowed. But whatever, there is one thing in code and what practice which we do in the live projects, I can say 90% cases we follow the code. But in lot of cases, there will be there will be situations when you cannot comply to 100% to the code. In such cases, consulting practices means general how is the design process that is followed in the industry. Whether say some 10% of the footings, 10% of the uplift, 10% loss of contact is allowed. So this is the consulting practices. So you should know both the things. You should know the codal provisions. You should also know what is the consulting practices which is followed in the industry. Whether for all the cases no uplift is allowed, or for gravity, or say for wind or earthquake actions which are not all the time acting on a structure, where maybe in such cases we can allow the footing. So this is called as a judgment based call. So you should be knowing all of this in the interview this thing. So yeah. So moving on to the next part. So yeah, like this. So all the elements, so they might even give you a column design, they can even give you a slab design also. So you should understand when